This is section 5.2, solving systems of equations, 3 equations and 3 unknowns. So it's going to be definitely harder than the 2 by 2. So we have 7 to 23 odd, and I'll show you some of each of those. Okay, on page 455, you have 3 equations and 3 unknowns, x, y, and z, not just x and y. So they're generally going to be longer to figure out. 17, 19. I have to raise the book up in order to see everything. It's hitting up against the document camera, so the only way I can show it is that way, unfortunately. Okay, I think that covers everything. Okay, number 11. So they have 3 equations, x, y, and z. This one is easy. Negative 2z equals 1, divide by negative 2. Z is negative a half. Then I plug in here, y plus 4 times negative a half is 0. That's y minus 2 is 0, so y is 2. Then I plug back into the first equation, 2x minus y, which is 2, plus 6 times negative a half equals 5. 2x minus 2 minus 3 equals 5. 2x minus 5 equals 5. 2x equals 10. X equals 5. So the order triple is 5, 2, negative a half. Okay, 15. It just asks to eliminate x in the third equation. That's all that the question asks for. So one way to do it is to multiply the second equation by negative 3. That way this would be negative 6x minus 6y minus 3z. Add it to 6x minus 5y minus z equals 7. That eliminates the x, and that's all the question asks for. Okay, 17. Solve this equation. If I add the first and third equations, x drops out. Y also drops out, so I have negative 3z equals 9. Divide by negative 3, z is negative 3. Plug back into here, 2y plus negative 3 is negative 1. Add 3, 2y is 2, so y is 1. And then I plug back into the top, x minus y, x minus 1 minus a negative 3 equals 4. That's x minus 1 plus 3 equals 4. That's x plus 2 equals 4, or x is 2. So the order triple is 2, 1, negative 3. Okay, 21. If I add the first and third equations, z gets eliminated. 3x plus 2y equals 7. And then I took negative 3 times the first equation. Gives me negative 3x minus 3y minus 3z equals negative 12. Add it to the second equation. That gives me another equation that doesn't have a z. Negative 2x, that's gone, equals 2. So x is negative 1. X is negative 1. Plug back into here. 3 times negative 1 plus 2y equals 7. Negative 3 plus 2y equals 7. 2y equals 10. Y equals 5. And plug back into the top equation. Negative 1 plus 5 plus z is 4. That's 4 plus z is 4. Z is 0. So negative 1, 5, 0. 25. If I add the first and third equation, z drops out. 5x plus 3y equals 3. Then I multiplied the top equation by, multiplied the bottom equation by 3. 3 times 3x minus y plus z equals 1. Multiplied by 3. 9x minus 3y plus 3z equals 3. And I combine it with the second equation. And if I add them up, I get another equation that doesn't have a z. So 10x minus y equals negative 1. And I have this second equation, 5x plus 3y equals 3. So I just have a regular 2 by 2. So I multiply this equation by negative 2. That way this will be a 10x, this will be a negative 10x. Negative 10x minus 6y equals negative 6. Add them up, x drops out. Negative 7y equals negative 7. Y equals 1. Okay, so y equals 1. Plug into here. 5x plus 3 times 1 is 3. 5x equals 0. X equals 0. Excuse me. Then I have 3 times x, 3 times 0, minus y, which is 1, plus z equals 1. And that's nothing. Add 1, so z is 2. So 0, 1, 2 is the final answer. Okay, 29, I'll show you how to do substitution. So substitution, I solve for z, add z to both sides, subtract 1. That gives me x plus 2y minus 1 equals z. Then I pick this whole thing up and plug into z right there and right there. So 2x plus 3y minus 4 times z, x plus 2y minus 1 equals negative 3. This is z, and this is also z. 3x plus 6y minus 3 parentheses x plus 2y minus 1 equals 4. All right, so this gives me 2x plus 3y minus 4x minus 8y plus 4 equals negative 3. That's negative 2x minus 5y, subtract 4 is negative 7. Multiply both sides by negative 1, 2x plus 5y equals 7. The second one, however, did something interesting. 3x plus 6y minus 3x minus 6y plus 3 equals 4. The x's drop out, the y's drop out. I have 3 equals 4. That's a contradiction. So you end up with no solution. Right? So this is how you do some of the 3 by 3s from section 5.2 in this chapter.